Imagine this. You're standing on the surface of Mars, a world that has fascinated us for generations, and beneath your feet lies something no space agency ever expected. Not frozen oceans, not ancient riverbeds, but something far stranger. Something that China's Zhurong rover detected just before it fell silent. Zhurong's mission began like any other rover campaign, mapping rocks, analyzing soil, scanning the atmosphere. But deep below Utopia Planitia, the rover uncovered signals that didn't match the natural geology of Mars. Smooth layers where there should have been chaos, arc-shaped boundaries where randomness should rule. Zones of unexpected density arranged almost like structural ribs hidden under the planet's surface. And the deeper the radar scanned, the stranger the reflections became. These weren't vague hints or fuzzy shadows. Zhurong mapped sharp contrasts, clean boundaries, echoes that looked engineered, not formed by nature. Mars was supposed to be lifeless, simple, predictable. But these readings threatened to rewrite everything we thought we knew about the planet. Before going offline, the rover transmitted one final data set, a scan showing multiple nested formations stretching several hundred meters long, all sloping in the same direction at identical angles. That precision lit a spark of confusion across the scientific world. Was this fractured rock? Could it be ice, melting and refreezing over millions of years? Or was it something far more unusual, something that required processes we've never observed on Mars? What Zhurong found echoed none of our geological expectations, and that's exactly why NASA, ESA, and CNSA scientists began poring over the data with a sense of urgency, because if these structures are real, if the subsurface of Mars is hiding something carefully shaped, then the history of the red planet becomes far more complicated. I'm Alex McCowan, and you're watching the Astrum-style breakdown of one of the most mysterious discoveries ever made on Mars. Today, we'll explore the final scans from Zhurong, the buried formations scientists can't explain, and the theories that could finally reveal what lies beneath the red planet's surface. And trust me, the deeper we go, the stranger it gets. When researchers first saw Zhurong's radar readings, the initial reaction was confusion. Ground-penetrating radar is supposed to reveal basic geological layers: sediment, rock, ice, maybe pockets of dust. But instead, the rover captured a sequence of clean reflectors sloping uniformly across its path. It was as if Zhurong had driven over the remains of something once hollow, now filled in by millennia of compacted soil. Several independent teams tried to model the signals. The closest match? Curved shells of material arranged in nested patterns, repeating consistently, not the randomness expected from lava flows or erosion. Mars, as far as we know, doesn't have tectonic plates, doesn't have deep oceans anymore, and doesn't have the interior heat needed to form cavern systems of this shape. And yet, the data suggested exactly that: cavities, long-gone voids, buried structures of unknown origin. The question wasn't just what carved them, it was when. Some scientists proposed ancient ice masses that melted away long ago. But the shapes didn't align with known glacial retreat patterns. Others suggested collapsed lava domes, but Utopia Planitia isn't volcanic. So the team turned to something unexpected: the electromagnetic signature itself. The reflections coming from some layers were stronger than anticipated, suggesting materials denser than normal Martian rock. Not metal, but something with higher dielectric contrast, something that once occupied those cavities and faded over time. A volatile compound? A rare mineral? Perhaps something that reacted chemically with the surrounding soil, leaving ghost-like boundaries behind. Meanwhile, ESA reanalyzed gravity data from Mars Express.
The results revealed slight negative mass anomalies, small dips in gravitational intensity, directly in the region Zhurong explored. Those dips correlated with the rover's radar map almost perfectly. 3 datasets from 3 independent instruments pointed toward the same mystery. Something large once existed beneath Utopia Planitia and left behind a signature we still don't understand. Could it be the remnants of ancient subsurface lakes? Could the repeated curves be sedimentary layers formed by long-lost tides? Or is this evidence of something completely unprecedented? Zhurong's silence came at the worst possible moment. With dust covering its solar panels, the rover shut down right after discovering the most puzzling subsurface features ever recorded on Mars.
What if Mars once had environments capable of reshaping its crust in ways we've never imagined? That's the question driving the scientific debate now. Because if the formations Zhurong detected really were shaped by water, then they may represent some of the last reservoirs that existed on the planet, and understanding them could reveal whether life ever formed beneath the surface. Beneath Earth's deserts, cave networks develop through chemical reactions, erosion, and water flow. On Mars, similar processes would require conditions far warmer and wetter than what we see today. So, did such conditions exist deep in Mars's past? If so, the buried formations could be the fossil remains of underground habitats. But the uniformity of Zhurong's reflectors complicates things. Water erosion rarely forms perfectly angled, repeated layers. Nature tends toward chaos, not order. A NASA geophysicist reviewing Zhurong's scans remarked that the subsurface geometry is too clean, too consistent, too deliberate, and that's where the controversial theory arises. A small number of researchers proposed that what Zhurong found might be the remains of ancient structural voids, not built by life, but by natural processes we haven't discovered yet. Processes that create patterned cavities, compress surrounding material, and leave behind curved shells, detectable through radar even after millions of years. It's not a claim of aliens. It's a claim that Mars may have undergone geological transformations foreign to Earth. But another group took a different approach. They proposed these shapes could be related to phase changes in subsurface ice. When ice forms, melts, and sublimates repeatedly in confined pockets, it can reshape surrounding materials into geometric layers, ribs, arcs, and shells. If this is the case, then Zhurong may have just found the strongest evidence yet that Mars once had long-term subsurface reservoirs capable of melting, freezing, and sustaining cycles similar to those that stabilize underground lakes on Earth. And beneath those reservoirs, conditions that could support microbial life. Now the debate shifts to a bigger question. If Mars once had habitats beneath Utopia Planitia, where did the water go? And why do the cavities look so sharply defined, almost preserved? Whatever the answer, Zhurong's data leaves one fact clear. Mars's subsurface hides a history far stranger than anyone expected.
The mystery left behind by China's silent rover is now reshaping future missions. NASA's upcoming Mars Sample Return, ESA's XLR's program, and China's proposed Mars lander for the 2030s may all shift priorities because of these findings. The underground structure Zhurong mapped might become the next target for deep drilling. If they truly are remnants of subsurface habitats, then they could hold preserved chemical signatures, fossil molecules, organic compounds, maybe even trapped gases from an ancient Martian environment. But before we leap to conclusions, we need to consider the final theory, the one quietly circulating in scientific circles. It suggests that the cavities Zhurong detected aren't geological or hydrological at all. Instead, they may be remnants of massive, impact-driven shock patterns created long ago. When a large meteorite strikes, shock waves can propagate through subsurface rock, compressing material into curved shells that resemble artificial structures. These layers can remain stable for billions of years, especially in Mars's quiet environment. If this theory is right, Zhurong may have discovered the fingerprints of an ancient planetary trauma, frozen scars left behind by an impact powerful enough to alter regional geology permanently. But even this explanation leaves questions unanswered. Why are the layers so uniformly spaced? Why do they extend so far? And how did they maintain such sharp boundaries after eons of burial? For now, no single theory fully explains what lies beneath Utopia Planitia. And that's exactly why the scientific world is so captivated. Zhurong, despite lasting only a fraction of its planned timeline, managed to deliver one of the most puzzling sets of data in Martian exploration. It left us with more questions than answers, more intrigue than clarity, and a mystery that may define the next decade of planetary science. As we prepare for the next missions to Mars, one fact is unavoidable. The red planet hasn't given up its secrets yet. Something buried beneath its surface is waiting to be understood. And whether it's geology, ancient water, or something entirely new, Zhurong has already changed the story. Because the moment its radar signals returned those impossible shapes, Mars became a far more complex world than we ever imagined.